Hello guys, I hope you guys are doing good. So this is a short video on factoring special cases. So let's go ahead and get started. So factoring special cases. So there's really two cases that we're really going to look at. Well, actually three, but they fall under two categories. The first category is we have factoring a perfect square trinomial, and this is the format right here. So normally you're going to see some number a squared plus 2. 2 is a constant, times some number a times some number b plus b squared. So typically we say a squared plus 2ab plus b squared. And then another one has a format a squared minus 2ab plus b squared. And then the other category that we fall under is factoring a difference of two squares. Okay, and this is these are just two of the most recognizable formats for when we factor. That's what we call special cases. So this one we normally recognize it when we see a squared minus b squared, and that'll give you this. So let me give you an example why in particular this side is equal to this side, which is also equal to this. Okay, and so that's kind of what we're what I want you guys to see here is that this side will be equal to this side, which is the same thing as this. And so I'm trying to get you to see that these are really just the same thing. Okay, so let's get to it. Example number 1. Okay, so I'm following the book too as well. So example number 1, I have a perfect square trinomial. I gave you the sort of like the what you need to know right here. So let's see. I'm going to ask you something like what is the factored form of, and then I'm going to give you x squared plus 14x plus 49. Okay, so the first thing that I want you to recognize is be like, okay, you know what? There's a reason why we call it a perfect square trinomial. So if you think about perfect squares, they're just your perfect squares, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on, right? So I want you to look for the perfect squares, right? There's a little 1, right? 1 times 1 is 1. That's a perfect square. Also, this one right here is a perfect squared, right? So you can rewrite it and say, okay, this is this right here, right? 7 times 7 is the perfect square, right? If I keep this going over here, 7 squared is 49, right? 8 squared is 64, and so on. 9 squared is 81, right? So 7 times 7 gives you 49. So this is your perfect square. So you can rewrite, right? We can rewrite your 7 squared again, because we know that 7 squared is 49, right? So we can rewrite those two. So the next thing that I want you to see, okay, is that, yes, this is your a, right, plus, right? So we're looking at this example right here. This is your b, right? And if you put a 2 here, right, you should have a times b. So again, that's where that middle term comes here, right here, okay? So what's 2 times a, I'm going to sort of do this on the side here. What's 2, all right, what's my a over here? 1, right, times your b, which is 7. So if you do 1 times 7, 2 times 1 is 2. 2 times 7 is 14. So it does satisfy, again, that perfect square trinomial section. So that tells us something. We can rewrite it like this. Okay, so that means that I'm going to rewrite it as in my format a plus b times a plus b. So again, my a is a 1x, so I'm going to do 1x plus b. What's my b? 7. All right, and then I'm going to go ahead and rewrite it times another x plus b, right? So again, this is the same thing as saying x plus 7, right? X plus 7 what, guys? Squared, right? And so this this is your answer. Okay. Now, if you want to know why this is the same thing as this, you can literally work the whole exact thing out if you want to. So if you were to go backwards, right? Backwards. You could do something like, okay, well, I want to work out what x plus 7 squared is. Well, that's just 7 plus x times 7, times x plus 7. So x plus 7 times x plus 7. Again, x times x is x squared. X times 7 is 7x. 7 times x is 7x, right? 7 times 7 is 49. Right, so if you work these out, x squared, right, add these two up, you get 14x plus 49. And again, that's going backwards. Does this give us that? Yes, absolutely. It gives us x squared plus 14x plus 49. So that is the power of knowing this form, because if you know this form, then you can automatically get to that form, and that's really, really useful. Okay, it's one of those forms that you want to memorize. Hopefully that makes sense. So again, my magic answer that I want to get you to get is from here to here. Okay? All right. So I'm not going to be mentioning this anymore. That was just for me to show you. But let's go back to doing another one. Let's see. How many minutes am I at? I'm at 6:30. Okay. So that's example 1. Let's go ahead and there's another really good example in the book. You can go do this one quicker since I already explained that one a lot better. So let's do, I'll do, this is B, example B in your book, so it's 1B. So I have 9x squared minus 30x plus 25. Again, we want to go ahead and identify what is my A and what is my B, right? So normally it should be A x squared minus 2a times b x, I believe, right, plus b squared. And again, right, what's a perfect square root of 9? Well, we know it's 3, right? So 3 times 3 gives us 9. Okay, what's a perfect square root of 25? That's 5, right? 5 squared is 25. And if we look at this part right here, well, guys, multiply your A and your B. What do you get? Right? What's your A times your B? Right? What do we get? We get, I believe we get, let's see, I want to do it in orange. I want to mess up. Your A, right, times your B, right, is 15, right? But you write it down, so it's 3 times 5, right, x. So, again, so 3 times 5 will give you, so 3 times 5 will give you 15, times 2 will give you your 30 that you're looking for, and that negative makes it negative, right? So that works. So that is exciting. I forgot the plus sign here. That is why we like this form. So from here, it's useful because now we have, we know that this right here satisfies my, again, my second condition for being a perfect square trinomial. So if we know that, then we could just write it out and say, okay, well, my form tells me that it's going to be a minus b times a minus b. So we just got to put what a is. So my a is 3x, right? So this is my a. What is my b? So my b is 5. So I'm going to do minus 5. And then again, I'm going to do 3x minus 5. And again, over here, what does this tell us right here? Our perfect square, it's a minus b squared, right? So we know that it's going to be 3x minus 5 squared. So this is my answer. Again, why does that give you that? Go ahead and multiply this backwards, and you will see that it actually works. Okay, but we're sort of like we're taking shortcuts now. We're trying to memorize forms. So we're at 9 minutes and 29 seconds. Let me go ahead and do another one. So we're gonna go back to so this is gonna be, let's see, what page is this in your book? It'd be great if you guys could do this and follow your book too. That'd be awesome, but you guys don't have to, right? Just saying. So that's 1B. Let me go ahead and use another color like blue, for instance. I'm waiting for my book. And of course, my internet decides to lag. So I'm going to pause this for a second. Hey guys, so my internet's back up finally. It didn't take much. It was like 5 seconds. But anyway, so now we're going to do the other format that I'm trying to show you, right? Factoring a difference of two squares. So let me go ahead and do that one. So let me give you example 3a. Okay, so this one, the easiest one would be something like this. Okay, and again, you recognize that that is a difference of squares. This is what we call it, a difference of two squares. When you have a squared minus b squared, and the a and the b are, right, your perfect squares, right? So let's go ahead and get to it. So again, this is your, picture this as being your a, right? So, and this is your b, right? So this is your b squared. So because you have your perfect square, sorry, I meant to write this, minus perfect squared, 3 times 3 is 9, right? So that's your perfect square. So when you have something like this, and you can rewrite it, and our format tells us when we're subtracting here, right? You're gonna have 1 plus and 1 minus. So that's as simple as that, guys. You're gonna have x, right? Your a and your b, x minus 3, and then x plus 3. And again, if you want to know why this works, you can go backwards, right? And multiply that out, and you're going to see that you're going to get that. But I'm not going to do that. Another super, so that's difference of squares. I really don't see much to it. I think 4a looks like this. Let me just quickly do it. 4x squared minus 81. Again, you see that's a difference of squares because that's 2x squared minus 9 squared. So, right, our format tells us that we're going to do 2x minus 9 times 2x plus 9. And again, that's because it's the difference of squares, and this one's a perfect squared, right? The 2 is a perfect squared, and the 9 is a perfect squared of 4 and 81. So that works. All right, let's do the last one. So now I'm going to give you something that looks like this. So I believe we have, let's see, 3. So this is example 4. And the last one I'm doing. So I have 3x cubed times y minus 12x y cubed. And again, this is combining everything that we have learned now. Okay, so if I give you something like this, the first thing I want to do, I want to go ahead and factor the greatest common factor. Okay, so the greatest common factor here would be, let's see, the least common, the greatest common factor between 3 and 12 would be 3, right? The greatest common factor, so you look at your x's now, right? Which one has the lowest exponent? That has a 3 and this has a 1. So I'm going to take an x to the power of 1. And then I'm also going to look at my y's, right? So I'm going to put a little circle around my y's. My y's, you look at the powers. This has a 3 and this has a 1. Well, I'm going to take the one with the lowest power, which is a 1. I don't want to confuse you guys and think that's a 0, right? So I'm going to take y to the 1. So this is my greatest common factor. I'm going to go ahead and factor that out, 3xy, right? So then I have this beautiful thing, and I just want to be multiplying inside. So 3 times 1 gives me 3, right? X times x to the power 1 times x squared gives me x to the power 3. That checks. I already have a y there. I don't care about that, right? 3 times one number will give me negative 12. That's 3 times negative 4, right? And then I'm going to go ahead and put y to the power 1 times y to the power of 2 will give me, right? 1 plus 2 will give me what, guys? 3 there, right? Right, so because of that, I'm going to leave it as that. So that gives me 3xy, x squared minus 4y squared. Again, they kind of want you to see here that this is a difference of squares. So 3xy, let me just type it in. That gives you x plus 2y and x minus 2y. Right, and that is your difference of squares. That satisfies, again, this is the difference of squares.